So directed stimulus is a manually crafted to verify a specific feature of the design or to hit a specific functional coverage point. Okay, so like functional coverage we all know. In order to check the functionality, how much we have covered, we will write functional coverage. So in order to specify a certain feature of a design, you need to hit that thing, right? So for that we can go with directed stimulus. Not all of the stimulus need to be directed. Like initially, for some initial configuration, we will go with directed stimulus, but after that we have to automate the process and we have to create the random values. So random values can be used to fill the portion of the stimulus that are not directly relevant to the feature being exercised. Okay, so as I told you before itself, for example, the content of a packet payload is irrelevant to the correctness of the packet routing. Only that is to be transferred unmodified. What they are trying to say is, suppose there is one packet. You take an example of a USB packet. Okay. So in USB packet, the objective is to send the data packet. Okay. So but the content of the data, it should not be manually written, right? It may be any data. Okay. But whatever you are transmitting, you need to receive the same data at the other end. So that is only the objective. So similarly, they are taking an example of a Ethernet packet. Okay. The integrity of the data is taken care by the CRC, but routing of the data is taken care by the directed stimulus. Okay, data you create any random data, but routing should be taken care by the directed stimulus. Similarly, the content and identify of the general purpose register used in an add instruction is not relevant, as long as destination register eventually contain an accurate sum of the various contained in the two source register. So now they are taking example of an add instruction. So in assembly language, we know the objective of add. It will take the content of the source register and destination register. It will add and it will keep the data in the source register. Okay. So we only need to check whether sum is right or not, and it is in the source register or not. That is what they are trying to say. Not what data is there. What data. Now we'll see some of the general exceptions. Okay. So by default, transactor will execute transaction without error as fast as possible. So that is the objective of transactor. Like it will create it will take a transaction and it will execute that thing. However, the verification of a design requires that the limits of a protocol be stretched and sometimes broken. Okay, so like every protocol is having their limitation. So but the objective of verification engineer is to verify the design even at extreme cases. Means it has to verification engineer need to stress the design as much as possible in order to check the integrity of the protocol. You can say that in order to check the means how much stable the protocol is. Okay, how much bursty traffic the protocol can handle. So verification environment and the transactor that compose it, it must provide a mechanism for injecting exception in the execution of the transaction. But when you are so in a verification environment, when you are developing a verification environment, during that time we need to give an option. Okay, when we need to inject some of the exception cases. Okay, so we'll see what all the recommendation they are giving when we need to create the exception in the verification environment. Exception should be described separately from the transactions. So suppose you want to write a you want to add this feature, exception feature, in your transaction, so you have to model that thing separately. So we'll see how whether directly or randomly injected exception should not be determined when a transaction descriptor is generated. So in normal cases, even in random cases, okay, we should not generate this type of exception, although quite feasible for the transaction that are generated immediately upstream of the transactor, where there is one-to-one correspondence between generator and what the executor. It become impossible to control when generator is removed from the transactor that must inject the exception through the multiple transactor sublayers, and when the same transaction can be executed on a different transactor, each with different possible exceptions, enabling an injection of a protocol exception. First we are creating an environment. Okay, then we are calling randomized kernel. Now see, you can see here constraint mode 0. Okay, you are disabling the constraint mode. Okay, this means that when you are using this constraint mode equal to 0, means whatever constraints you have used, okay, that is getting disabled now. So enabling the injection of a protocol exception. Okay, so how you are enabling